In this video, we will be discussing the electrocardiogram, or ECG for short. The word electrocardiogram can be separated into three parts: electro, cardio, and gram, practically meaning an electrical heart drawing. The ECG provides us with a visual representation of depolarization wave movements during each heartbeat. We know that the heart contracts. This is a routine practice that enables the heart to pump blood throughout the body, but it wouldn't be able to do this without the help of a specialized cardiac muscle known as myocytes. These cells are unique because they can generate and conduct electrical impulses. The heart's electrical system is organized into a specialized conduction pathway. It starts at the sinaural atrial node, often referred as the heart's natural pacemaker. This small cluster of cells initiates the electrical impulse that triggers each heartbeat. From this node, the impulse spreads through the atria, causing them to contract and push blood into the ventricles. This process is known as atrial depolarization. Then the impulse travels to the atrioventricular node, where there is a delay. This delay allows the ventricles time to fill with blood before they contract. Once the impulse passes through the AV node, it travels to the bundle of His and into the Purkinje fibers, leading to the ventricular depolarization and contraction. Let's take a closer look at cardiac muscle cells. In the resting state, these cells are naturally negatively charged. However, when they're depolarized, meaning when the electrical impulse travels through them, their internal charge becomes more positive. So what even is a dipole moment? A dipole moment arises when there are two equal charges of opposite signs. In this case, it refers to the transition from a negatively charged resting state of the cell to a positively charged depolarized state. The dipole moment points from the negative region to the positive region within the cell. This shift in charge is significant because it generates an electrical signal that is reflected as a positive deflection on the ECG. Essentially, as the heart muscles depolarize, it creates this dipole moment. The ECG records this change in electrical activity as an upward spike in the graph. And the opposite happens for the repolarization. The dipole moment switches and the ECG records it as a negative spike.